The atomic structure. That's what we're going to be talking about today is what is an atom? What makes up atoms? What things are made up of atoms? So we're going to be talking about pretty much atoms today. So let's get rolling. The atom. Fun fact before we get started, the word atom is derived from the Latin word atomos. The A means not, and tomos means to cut. So not cut or atomos really just means uncuttable. So atom comes from the word uncuttable. So before we get started, really, I've got a thought project for you. What if we took a pure bar of gold and I chopped it in half? And I took that half and then I chopped that half in half. And then I halved it and then halved it and then halved it and then halved it and halved it and halved it and halved it. Could I do that forever? Well, the correct answer to that is not really. We could get all the way down to where we got one single atom of gold. Then I couldn't chop that atom in half anymore. So the word atom comes from, again, uncuttable. We get all the way down to a single atom. We can't chop it anymore. The definition of an atom: atoms are the smallest unit of matter, or the building blocks of matter. So literally everything that is made of matter, your table, you, the floor, a bouncy ball, anything is made of atoms. If it exists, it is made of matter, therefore is made of atoms. The atom. The atom itself is actually made of smaller individual pieces known as subatomic particles. So sub meaning below. If you think of the word submarine, submarine, the submarine goes below the ocean or into the ocean. So subatomic, below an atom or smaller pieces of an atom. So subatomic particles or subatomic units. The atom may be the smallest unit of matter, but they're also made of three fundamental parts known as the subatomic particles. So there's three of them that I need you to know. The proton, which is in blue here, proton, the neutron, which is in orange, and the electron. These guys whizzing around on the outside are known as the electrons. The atom. So let's focus on the proton first, these blue circles in the middle. The proton is a positive subatomic particle and has a positive charge. So proton, positive. Proton, positive. Protons do have a measurable amount of mass. So we can actually measure those out. It might be really, really, really tiny, but we can get the mass of a single proton. Protons are located in the central region of the atom known as the nucleus. So this center area right here is known as the nucleus. Next one, the neutron. We're going to hint on this in physical science just a little bit. We're really more focused on the protons and the electrons, but while we're talking about the subatomic particles, we are going to have to talk about the neutrons. The neutrons are the neutral subatomic particle of the atom and therefore have no charge. So neutral, neutron, no charge. And they hang out also in this middle area known as the nucleus. Now, the neutrons do have a measurable amount of mass. We can figure out how much one single neutron has as its mass. We can measure that. The last one is the electron. Electron is the negative subatomic particle. These guys are whizzing around on the outside here. It does have a negative charge. So electrons, negative. Electrons, negative. Electrons do not have a measurable amount of mass. We cannot figure out how much mass one single electron has. They're just too teeny, teeny, tiny, and they move so fast around the outside of this atom. Electrons are located in the outer region of the atom, known as the electron cloud, and they are whizzing super fast around out here. And we're going to really be focusing this whole entire year mostly on the electrons. These are the most important. So, quick review of each one. Proton, going to be super important for us this year. Neutron, not so important for us this year. Electron, really, 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 really important for us in physical science this year. So, The elements. Elements are different types of atoms based on varying number of protons. They're organized on the periodic table of elements. You might have seen one of these maybe in like a science show, and they've got this in the background, probably on a giant poster. You might have seen it in your science classes before. This table is going to be super important for us. So let's look what happens as we increase the number of protons. We start in the top left hand, and we're going to read it like a book and go across and down like such. If we have just one single proton, one, one, and one, we have hydrogen, and it hangs out here. Let's see what happens if we increase this number to 2. Boom. Again, we're reading it like a book. 2, 2 protons, 2 protons, 1, 2, means we have helium. Change it to 3. 3, 1, 2, 3, 3, lithium. Go check out the next one. Beryllium, 4, 4 protons. 4, 1, 2, 3, 4. And boron, 5, 5. 1, 2, 3, 4, 5. And we can continue this pattern on 6, 7, 8, 9, 10, all the way down. Keep going, keep going, keep going. 73, 74, 75. Just keep increasing those numbers. You can get all the way up to crazy numbers like 118. We even can go a little further than that. Okay, so as long as we're increasing the number of protons, we're changing the element, what they are. So the atomic number is the number of protons in the atom. So right up here, this little number up at the top of each one of these tiles tells us how many protons we have. However, the number of protons is pretty much always equal to the number of electrons. That's not always the case, but for the vast majority of this class and everything we're going to pretty much be doing, that is pretty much going to be the case 99.99999% of the time in our physical science class. So if you want to think about protons matching the number of electrons, it works out. So the atomic number can also help us figure out the number of electrons. Now the atomic symbol is this letter in the middle here. The atomic symbol is always capital. Always capital. I'll say that one more time. It's always capitalized. I know some of y'all send emails and text messages, etc., and you don't capitalize the first letter of a sentence. Well, if you don't capitalize the first letter of these elements, it's wrong. Period. The end. It's wrong. Okay? Sometimes it can be 2 letters, but the second letter is always lowercase. So we have ZN, HE, AG, and LI here. The first letter is capital, the second letter is lowercase. That's important. The elements and the atomic symbol are not always the first letter of the word in English. So in this case, I picked carbon, and so we had C, C, and C, but that's not always the case. In fact, gold is AG. This comes from some of these elements being discovered in other countries, or sometimes when the element is discovered, um, the element itself, um, first letter is already taken. So some of these have different letters like ZN and HE and AG and LI. Doesn't always match the first letter of the word in English because English isn't the only language in the world. Last bit here is the atomic mass. The atomic mass is the combination of the number of protons and neutrons because they both have a significant amount of mass. The electrons really aren't involved in this at all because we can't get the mass of the electron. The number of neutrons aren't always the same because which leads to us averaging this number, which causes these decimals. So sometimes you'll see that the atomic mass isn't like 12. It might be 12.01 or 15.99 because we actually average it because the neutrons sometimes are a little funny. Sometimes we have extra neutrons, sometimes we have not as many neutrons. It just is what it is. We're actually going to wait until chemistry to really get into that, so it's not super important for us. But while we were talking about these tiles of each one of these elements, that number right here is kind of important to talk about. All right, so quick review of everything super fast. We were talking about the atom and its structure. Atom, fun fact, means uncuttable. Just like if you were to take a bar of gold and chop it and chop it, chop it, chop it, chop it, chop it, chop it all the way down, you get to a point where you couldn't cut it anymore and you'd get to a single atom. Atoms are the smallest unit of matter, or also sometimes called the building blocks of matter. Atoms themselves actually do have smaller units. These units are known as subatomic particles: the proton, the neutron, and the electron. Protons have mass, and they're positive. They hang out in the middle, known as the nucleus. Neutrons, these guys are neutral. They have no charge, but they do have a measurable amount of mass, and they hang out with the protons chilling in the middle here. Electrons, these are negative subatomic particles. Negative subatomic particles. They do have a charge, which is negative. The electrons have no mass, or at least measurable amount of mass, and they are whizzing around super fast on the outside of the atom, known as the electron cloud. This is going to be by far the most important subatomic particle for the rest of this year. The electron is extremely important. Elements. Elements are different types of atoms based on the varying number of protons. And they're all arranged on this thing known as the periodic table. As we increase this number, 1, 1, and 1, to 2, we change the type of atom. We went from hydrogen to helium. Change it to 3, we have lithium. Change it to 4, we have beryllium. Change it to 5, we have boron. And we continue this all the way down like we're reading a book, and we can get to crazy numbers like 118. That'd be 118 protons. It'd be a really big atom. The atomic number. The atomic number is this number up here at the top, and that is the number of protons. The atomic symbol. This is always capital, period, the end. Sometimes there's 2 letters. Some examples of 2 letters ones would be Zn, He, Ag, and Li. And they're not always the first letter of the word in English, because English isn't the only language that exists out there. The atomic mass is the combination of the 2 pieces that we can figure out the mass of, the protons and the neutrons. Sometimes this number is in decimals because we average those out. Sometimes we actually have extra neutrons. Sometimes we don't have extra neutrons. They can be a little wonky sometimes. So you'll see this number down here at the bottom, and sometimes it's a decimal. All right, that should sum everything up for this presentation. Best of luck.